Welcome back, folks. We are ready to rock and roll, and I think you're really going to like this video because it's stuff we already know. So this is going to be hopefully a really straightforward video for you guys to go through, take a look at. We're going to focus on concentration of solutions, talk a little bit about solubility and reactions, and go from there. So hopefully you'll find this a pretty straightforward video as we move forward. Hopefully by the end of this video, you'll be able to explain saturated, unsaturated, and supersaturated solutions. You should also be able to calculate molarity, molality, perform dilutions, and percent composition. We've got some vocab terms here. Again, nothing new, which I really like. Probably be one of the last videos where we're really just kind of rehashing things from first year chemistry. But again, I really think it's important that we at least talk about these things and make sure that you understand what the expectations are. Our vocab terms are unsaturated solution, saturated solution, supersaturated solution, molarity, molality, the dilution formula, and percent composition. So let's talk a little bit about saturation of solutions. So you probably noticed before, like when you've made Kool-Aid or something like that, because that's what the kids do. It's 2020. When you go home, what do? You make Kool-Aid. That's what we did in the 90s, but you know, go figure. You take sugar, you take Kool-Aid mix, and you put it in water. Now, there's a recommended amount, and then there's like what kids actually do. And they tend to pour a whole lot more sugar and a lot more Kool-Aid powder into it to give it more flavor. Well, at a certain point, the sugar will no longer dissolve. The reason being is that it has reached its saturation point. There's no more solute that can dissolve in the given amount of solvent. So in that case, we either need to add more solvent in order to get the rest of it to dissolve, or remove some of the solute that is present. Now, if we're below the saturation point, that is known as unsaturated. If we're above it, it's known as supersaturated. And this is typically found in grams per 100 milliliters. So really important to make sure that you know that, because we're going to be doing a lab where we're going to be looking at a solubility curve and looking at the saturation points and determining how does temperature play a role in that. Now, at a certain temperature, you can actually get a supersaturated solution. So typically when you heat something, you can dissolve more solute into solvent. When you cool it back down, it has become supersaturated. That being that at that particular temperature, you have too much solute that is dissolved in solvent. When this happens, crystals actually form at the bottom of the solution. Let's start with this first practice problem. It says, how many grams of potassium chloride will it take to prepare a 500 milliliters, saturated solution rather, in 500 milliliters of boiling water? Solubility is 56.7 grams per 100 milliliters of water. All right, so this is pretty straightforward. We can actually set this up like a proportion. If we know that 56 grams go into 100 milliliters of water. Sorry, I'm using a new stylus today. And we want to know how many grams we're going to get in 500 milliliters. Well, we set up a proportion like that and we plug in and solve. It's pretty straightforward. So X here is going to be 280 grams. Okay, pretty straightforward there. Now there are a couple other things that you can do with this, so it's really important to make sure that you are aware. Remember, 1 milliliter is essentially 1 gram of water. So it could give you mass of the water, it could give you kilograms in mass of the water, and you would need to know how to be able to go through and do the conversions there. All right, let's move on. So one of the things we do want to take a look at when we talk about solutions is concentration. Now, concentration typically relates to how much solute is dissolved per unit of solvent. If it's a weak concentration, then it will have fewer moles or grams per amount of solvent. And if it's highly concentrated, it'll have more grams or moles per unit of solvent. Essentially, we're looking at concentration, how strong it is. Now, we typically measure this in molarity. Molarity is capital M for representation, and it is just simply moles per liter. So moles of solute divided by liters of solution. Now, keep in mind, I can give you grams, I can give you milliliters, I can even give you grams of water, and you would have to know how to convert that. So keep in mind, there's a variety of different conversions that you can do here in order to be able to solve these types of problems. Let's do a couple. So let's take a look at each question individually. The first one says, how many milliliters of a 0.150 molar solution do you need to obtain 100 grams of NaCl? Since we're looking with big M here, remember that molarity is moles per liter. So we're given our molarity, which is nice. The question's clearly asking for volume. It's asking for it in milliliters. And here we're given grams. So in order to be able to solve this, we're going to first have to convert grams to moles. Okay. And then plug into our equation, solve for liters, and then convert liters to milliliters. So let's get started. We have 100 grams of NaCl. And we're going to convert that to moles. We have 1.711 moles. We're going to divide that by our unknown milliliters, and we're going to set that equal to our molarity, which is 1.500. All right, and again, make sure you do this correctly. Just multiplying these two on both sides is not going to solve the problem here. All right, so 1.141 liters. Okay, now remember, we have to convert liters to milliliters. So we're going to multiply that by 1,000. And what we end up with is 1,141 milliliters. Okay. So again, really important to make sure that you're plugging those numbers in correctly. You're solving for what you need to solve for there, particularly with this part. Okay. A lot of people still making mistakes on that. But also, please make sure that you're looking at where to plug things in for the molarity formula. All right. How many grams of ethanol are there, C2H6O, in a 200 milliliters of a 2.00 molar aqueous solution of ethanol? Well, again, we got capital M here, so this is a molarity formula. We're given volume. It's asking for grams. I don't know grams, but I can get that for moles. So let's start. And we'll use the same formula that we're using up at the top. So that's my molarity. We're going to set that equal to 200 milliliters. Make sure we convert that to liters. And we'll get moles. And then when we get moles, we just plug in and do some stoichiometry to solve 4 grams. So we end up with 0.4, yikes, 0.400 moles. Okay. And then we'll just use the molar mass to convert that to grams. Should we use correct number of significant figures? All right. Again, simple enough. Just really important to make sure that you go through, follow each step, and make sure you figure out what you know, what you don't know, and then work to be able to solve from there. Now, another way that we look at concentration is by looking at molality, which is a little bit different than molarity. Molarity is represented by capital M. Molality is lowercase m. The only real difference here is that instead of looking at liters of solution, we're looking at kilograms of solvent. Everything else is the same, though. We need moles of solute on top. We need kilograms of solvent on the bottom, and that will give us our molality. We don't use this very often, but we will use it in an equation a little bit later on when we look at, you're given 450.0 grams of a 0.7500 molal solution of NaCl dissolved in water. How many grams of NaCl are in this amount of solution? So we see the word molal. Okay, so we know we're going to use molality, so that's little m equals moles over kilograms. So we're given our molal. It's asking for grams of NaCl. We're given grams of our solvent here. Okay, so the key thing to look for here, because it's weird, because both things can be given to you in grams. You need to think about which is your solute and which is your solvent. Now, typically, we're dissolving NaCl into water, so water is going to be my solvent, and NaCl is going to be my solute. Okay, now it's asking for grams of NaCl. We'll solve for moles and then convert moles to grams. Pretty straightforward here. So 0.7500 equals, now 450 needs to be converted to kilograms, so that's 0.450. So with correct significant figures here, we're going to get 0.3375 moles of NaCl. And then we're going to convert that to grams. So 0.337 5 moles. Moles on bottom, grams on top. And we plug in and solve. End up with 18.85 grams of NaCl. And that's how much to make that concentration of solution. Okay. Again, pretty straightforward concepts there, but you'll read it, take it one step at a time, and you should have no problems with this whatsoever. Let's move on. So many times we are going to be given a solution of a concentration that we don't really want, and we want to be able to change the solution to that concentration. Well, in order to do that, we use a dilution formula. This is what I do when you see me in lab making new solutions. I'm using a dilution formula to figure out how much of one particular solution I need to add and then add water to it in order to dilute it to be a certain concentration that we're looking for in lab. In order to do this, we use a new formula. M1V1 equals M2V2, where M is the molarity and V is the volume. So we take the molarity and the volume of the first one, the molarity and volume of the second one, and then multiply them together, and you can solve a variety of different things this way. Typically what we do is I want a particular volume of a second solution, and so I'll know what M2 and I'll know what V2 is, and then I'll know M1 because I know my initial concentration, and I'm looking for V1 because I want to know how much of my initial material I want to be able to put in a beaker and then add water to it to be able to dilute it to the appropriate concentration. So we'll see that in our next practice problem. If you have a 3.00 molar solution of NaCl, how much of the NaCl solution would you need to dilute to get a 2.00 molar solution that is 400 milliliters? How much water would you need to add? So we have two questions here. The first one says, how much am I going to need to dilute? And the second one says, how much water would I need to add? Okay, so let's look at that first part of the problem there. How much do I need to dilute? Well, I'm given my initial concentration of NaCl, so let's call that M1. I need to know how much of that I need to dilute, so that's volume, that's V1. I have a second concentration that I want, and I know my second volume. So I just plug in to the dilution formula and solve very easily. So 3.00 times our unknown x equals 2.00, 400 milliliters. We can leave that. As long as the units are the same on both sides, you're perfectly fine. So you'll know here that x will be in milliliters. So using correct significant figures, I need 267 milliliters of my first solution. Okay, so that's going to answer the first part of the problem. The second one says, how much water do I need to add? Well, if I take a look at what I have here, I'm getting 267 milliliters of my original solution. I need my solution to be 400 milliliters. So I'm going to subtract 267 from 400 in order to determine the total amount of water I need to add to finish the dilution. So we're going to take 400 minus 267 to get 133 milliliters. And we'll just include water added. Okay? Again, a pretty straightforward concept here. Just make sure you notice the water added part. That's really, really important, and a lot of people will get tripped up on that, so pay close attention. The last problem I'm going to have you take a look at, and again, it's another one of those straightforward. I just wanted to breeze through some of these different ways that you can look at concentrations of solutions, is by percent composition. And percent composition is pretty straightforward. We can look at it by mass, volume, or mass volume. If it's by mass, it's grams of solute divided by grams of solution times 100. By volume, volume of solute, volume of solution times 100. Mass of solute divided by volume of solution times 100 if you're looking at mass by volume. Okay, so lots of different ways that we can actually look at these types of percent compositions. Just be aware that your units, if you're looking at grams, that's pretty straightforward. But if we're looking at volume, make sure that both are in milliliters or liters, depending on how you're looking at it. So again, pretty straightforward. Let's do a practice problem and call it a day. A solution is prepared by dissolving 25 grams of sucrose in 175 grams of water. What is the percent composition? Well, in this instance, we're going to use grams, so it'll be percent composition grams. And it already gives you both, so it's a straightforward. You just plug in and solve. We're going to take 25.0 grams divided by 175 grams. And then whatever we get there, we're just simply going to multiply that by 100 to get our answer. Very, very straightforward here. And using correct significant figures, we end up with 14.3% grams sucrose. Okay. Again, pretty straightforward here. Gasohol is a solution of gasoline and alcohol. Every liter of gasohol contains 90 milliliters of ethanol. What is the percent composition of ethanol? Again, same thing here. The only difference is instead of a liter, we're going to make sure that that's in milliliters. So we're going to take 90 divided by 1,000. Remember, these are milliliters. Times 100. I kind of feel like I'm going backwards here. And gasohol, ethanol in gasohol is 9.00%. Ethanol. Again, lots of just plugging in and solving different problems, but again, they won't always be this easy, but you should be off to a good start. All right, folks, just wrapping things up for today by the end of this video. Hopefully now you are able to explain saturated, unsaturated, and supersaturated solutions, and you can calculate molarity, molality, dilutions, and percent composition. My name is Jay Bio. Hopefully you got a lot out of this video, and hopefully it was pretty straightforward and easy to follow. We will talk to you later, guys. Have a great day. Bye-bye.